So we're here with SecureRF. So who are you?
So I'm Louis Parks. I'm the CEO of SecureRF.
And you make secure IoT? What do you do?
We actually develop security solutions that are very, very efficient, very, very small, that will fit on the smallest devices now making up the Internet of Things or IoT. So specifically authentication and data protection mechanisms for 8 and 16-bit microprocessors, and things as small as passive NFC and RFID, and things like Bluetooth Smart, and other devices where energy and speed are very important.
So let's see some of the stuff here. So this is...
So this is a...
what is that?
This is a FPGA from a company called Microsemi, and this is their Smart Fusion 2 latest board. And what we've done is we've got our solution, the algebraic eraser, running on it alongside elliptic curve cryptography, two asymmetric protocols. And I can show you the speed difference between the two by looking at the screen here. And on the screen I have two squares, and what's going to happen is I'm going to hit go, and in each case, every time that smart board computes an authentication, it's going to paint a line of pixels. There's 512. So I'm going to hit go, and you're going to see the speed at which we paint pixels against DCC. Go. So that's 512 pixels painted in 37 milliseconds. What's happening here, ECC is painting one line every 380 milliseconds. 3 a second still isn't bad, but you can see the speed at which it deploys. So this difference in speed and performance translates not only in terms of how quickly we can authenticate, but in significantly lower power consumption. So again, in wireless devices or things where power and energy consumption are important, like Bluetooth or any of the other wireless sensors that are making up the Internet of Things, that's the difference that we bring.
So do you get on ARM processors? Or?
Yes, and as a matter of fact, ARM has a range of processors, the smallest of which are the M0 and M3s. That's where our solutions run, because there are already other solutions that can run on the much higher, more advanced ARM processors. But absolutely.
Right. So are you shipping?
We are an ARM partner. We are shipping. We have pilots going now with major pharmaceutical companies, some defense contractors, a significant Department of Defense pilot going on now in the US. So we're just beginning to send out platforms commercially.
Because IoT is awesome, it's great, but if it's not secure, then it's going to fail, right? So it has to be secure.
Correct. The IoT and the industrial IoT, security, safety, privacy, very, very critical components for adoption.
All right. Why are you showing these over there?
Because what we're showing is these are passive NFC chips, and what we're showing is a solution where if you wanted to authenticate products in the IoT, we have an app, and this app will actually authenticate with a chip. There's actually a cryptographic engine running in the chip, so all I have to do to authenticate it is hold it up, hold it over the chip. When that turns green, I touch, and it's going to do an authentication. What's exciting and different about anything else that's out there, if you look at the phone, you'll see it's in airplane mode. So this did not use any server or back-end processor. It actually did an asymmetric or public key handshake between this phone and the chip in this tag to authenticate it. Unlike anything else that's running now on that type of platform.
All right. So since when do you have the solution working?
These solutions we've just introduced commercially earlier this year, including the FPGA solution. Some of our intellectual property has been around for a few years.
And then people can just add this to their IoT solutions.
Correct. So we are licensing it to semiconductor companies and working with partners, like an ARM and others, or they can get it with our code built on sensors, something like this, where we're producing a temperature sensor that's using an asymmetric authentication, doing 1 million temperature collection points, all encrypted and protected to ensure nobody tampers with the data or the authentication of the product that it's on.
All right. Is it compatible with the FIDO Alliance and all the other security that's going on?
We're a member of some alliances, but each alliance arguably is affiliated with a protocol or some algorithm method. So we're members of several. But again, we're providing the very base level asymmetric solution. So happy to work with whoever and whatever out there.